Hello, welcome to another episode of Exploring Rust. In this video I'm going to take a look at traits in Rust. I'm going to have to split this into a couple of videos, so I'm just going to look at the basics of using traits here. Because now that things have got a bit complicated, I'm really finding it hard to keep everything in my head even long enough to make a video on it. What I really need to do is just practice Rust, but it's sort of hard to practice it when I don't know enough stuff to really write any kind of interesting program. So I'm determined to kind of skim through the basics, and then I'm going to try to write some programs. Anyway, let's take a look at this. So a trait is apparently sort of like an interface. It's something we can use to add functionality to different entities, and we can also use it to specify what functionality an entity has. So I'm going to try to define a simple trait here, and I have already been through all this stuff and typed it out and got it working once, so it should go relatively smoothly. So I need the pub keyword apparently and trait, and then we need to give the trait a name. I'll call this stats, I think, and then we've got curly brackets, and I don't think there's a semicolon there because this is kind of a type definition. So now I can just define functions, except I don't give the functions any body. So for example, we could have a function sum, let's say that returns a i32, and then we just put a semicolon there. And because I intend to implement this on a struct, I'm going to put self there as well, so it can access struct data. So let's check if I've made any mistakes so far. Cargo format, cargo run, that seems fine. Now let's create some sort of thing that I might want to implement this trait for. So I'll have a struct point, and let's give that a x of type i32 and a y of type i32, and again no semicolon there. I'm just going to check that it compiles. That's fine. And now that I have something that I could implement this trait on, I could actually go ahead and implement this trait for this point struct. So to do that, I say impler. It's like implementing a method, I suppose you call it, for the struct. Do you call them methods or functions? Not really sure, but anyway, it's like implementing a function for the struct. So I say impler, the name of the trait for, and my struct. And now I can go ahead and implement that method. So the signature is going to have to match. I'm going to paste this down here, and then we're going to replace that semicolon with curly brackets and add in an implementation. Like for example, I could just say self.x plus self.y, and that becomes a return statement if I leave this semicolon off the end. I'll check this again. Yeah, it's fine. So far so good. And I can now create a point and try to use it. So let's say, let P1, or maybe just P, because I'm only going to have one of them actually. Let P equal point, that has curly brackets, doesn't it? And we've got to say X has some value, maybe 5, and Y can be 3. And I think I do need a semicolon there. Then I should be able to call this sum function or whatever it is on P. So let's try print line and double quotes, curly brackets, and p dot sum. Let's see if I've got this right. Moment of truth. So cargo, I'll just do format, cargo run. Yep, and it says 8, which is what I expected because I've got 3 and 5 in there, so that's fine. Now it's possible to define default implementations in structs. In fact, I think everything I've seen so far is extremely similar to a Java interface. So there's not really any surprises, it's just I find it pretty difficult to get the exact syntax right with Rust. It is unusually tricky, at least in my view. Anyway, let's create another trait here. Now imagine that I want to create it's not actually another trait, is it? It's another function, I suppose, that's part of the trait. Well, anyway, let's add another function in here, but I want to provide a default implementation for it. And here I run into a problem. So if I say function, I'm going to call this sum square, and let's say the idea of that is it should return the squared sum of both of the points fields. So we need self here, and this time I am going to provide an implementation so that we get an implementation which we could override later on. We could provide a particular new implementation for this trait, for this function in this trait, although I haven't actually tried that. But if we don't do that, I want there to be a default here. Now the problem is this trait has nothing to do with structs at all. It's simply that I'm choosing to define this trait for this struct later on. But at this point, and in fact even after this point, it has nothing to do with these point structs. So it doesn't know about x and y. So I can't access x and y in here. And I did find a way around this, however. What I have to do is create a couple of functions in here so that this trait stats that I've created expects to find that the entities it's defined for have methods for retrieving an x and a y. So let's create here function x. Let's put self there and return i32. And we'll have the same thing except it's going to be called y. So I can't provide default implementations for these. I'm going to have to implement them when I implement this trait. And if I say that this trait is implemented for this point, I am going to have to provide implementations for these, I think. For the moment, let's just get this to work by just returning 0 here and try to compile this. See what actually happens. Yeah, so it says not all trait items implemented. So if I'm saying that this trait is implemented for this entity, point, I am basically saying that point has all the functionality that's defined in the trait. And therefore, if these don't have default implementations, they will have to be defined down here or presumably in another impler block. I'm just going to copy those and paste those here. It doesn't really matter where. And then, now because I'm implementing this trait for this point, it does know about point fields. So I can do, actually I don't even need return. I can just say self.x, and that's now the return value of this. Actually, let's try just putting this all on one line. And then I'll run the formatter in a minute and we'll see if it agrees with this or not. So this is going to be y and that's going to be y. So let's see if that works. If I run cargo format and cargo run, okay, it didn't like that. I need to get rid of that is what I need to do. So I need these implementations. All right, I think I'm finally getting there. Let's try that. Cargo run and expected round brackets found integer. Why? Oh yeah, sum square. I've not actually defined a return value for this, so that's got to return, let's say, i32. And I don't really need return 0. Let's put just 0 in there and try again. Okay, now it's finally all right. So I can now implement sum square because I could do, and apparently to raise things to a power, even to square them in Rust, you have to use the pow function, which is seemingly associated with integers and other things. I don't quite understand how this works, but I'm going to do i32 : pow self.x, and I want to raise to the power of 2. This is pretty strange, but that's what seems to work. And we want to do the same thing for y. Then hopefully I should be able to use this sum square function. So if I go down here, duplicate this, I should be able to say square and print the results. So I should get 25 plus 9, which should be 34. So let's do cargo format. Hang on, did it leave my stuff on the same line that I put all on one line? Can't even remember where that, oh yeah, that was, no, I can't even remember where that was now. Okay, well anyway, stuff isn't on the same line. Okay, all right, never mind about that. Let's do cargo run. Okay, it doesn't like that. Method, not a field. Oh yeah, okay. So yeah, I can use X and Y, but the point is I have to use these methods now. So I need to put round brackets there. That was the whole point of defining them, so that I could use them here. All right, let's try this then. Yeah, it wasn't called square, it was called sum square. Let's put sum square in here and try again. Now it works and I've got 34 coming out down there. All right, so I don't think this syntax is too bad at all. It's just I'm really not fluent at all with Rust. And that's because I've done no programming in it aside from what you've seen me do in these videos. That's literally almost all that I've done, except that sometimes I prepare a bit for a video like I did for this one, and I basically typed out this stuff and got this working. I had to Google how to do this POW thing, for example. So I think in the next video we'll take a look at something called trait bounds and whatever is in the rest of this page on traits in the Rust documentation. It does say in the documentation that traits are similar to interfaces but not the same. At the moment I can't see how they're different. And I sort of wish I'd known this right at the start, because all along making these videos, what is this, like it's now the 20-second video, I've been kind of wondering what a trait is. And it turns out it's not that complicated. One day I intend to make a course on Rust, probably aimed at Java developers or maybe programmers in general. So not just me messing around trying to learn it, a proper structured course. And I think I'm going to try to put this trait stuff really early on, because it's been like a major problem not knowing what a trait is all along learning Rust up to this point. Okay, so I'm going to write this up as usual. It'll be on blog.caveofprogramming.com. You can check out this source code there, and I'll break it down and write it out in some logical order, although I think I managed to get this particular video in a fairly logical order. It's just that I made a lot of mistakes, as you've seen. So until next time, happy coding.